You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. You know, if you're working in tech, especially anywhere near operations and development, it just feels like you're trying to drink from a fire hose right now.
It is a total information overload every single week.
Right. So what we're going to do today is try to cut through some of that. We've honed in on a few things that are really reshaping the world of DevOps as we speak.
And we're really tracking two sort of seismic forces that are crashing into each other. On one hand, you have this incredibly fast integration of autonomous AI agents into, well, everything.
Yeah, into our actual workflows.
Exactly. And on the other hand, there's this constant foundational struggle for, just basic infrastructure resilience and good security hygiene.
And the stakes could not be higher. I mean, we have to talk about a maximum severity, CVSS 10.0 vulnerability, and at the same time, the just, frankly, embarrassing scale of a massive data leak from a tool we all use.
It's a huge reality check. It tells you the fundamentals are still a problem, even as we're building this crazy future.
So let's start with that future, the whole AI agent thing. Because if these things are going to be autonomous writing code, making deployment decisions, we need some rules, right? Some guardrails.
Industry-wide guardrails, and that's exactly what we're starting to see. The big news was the formation of the Agentic AI Foundation, the AAIF, back on December 9th. It's under the Linux Foundation.
And the names involved are just. They're the heavyweights. You've got Anthropic, Block, OpenAI, all co-founding it.
What's really interesting to me isn't just the names, it's the conceptual shift. They're trying to steward these core projects to create open, accessible, agentic AI. It's a new governance layer for software.
A new governance layer. So we're moving from developers writing config files to agents just interpreting our intent.
That's the idea. But you've hit on the key tension there. You have Anthropic with its Model Context Protocol, or MCP, Block with its Goose framework, OpenAI with agentsS.md.
So is this just a standards body to rubber stamp what everyone's already doing in their own silos? I mean, how does this help me if I'm using, I don't know, Hugging Face on Azure?
Well, that's the core question. These protocols are supposed to define how agents communicate their intent and execute securely. MCP, for instance, is all about making the AI's internal reasoning as context auditable.
Okay, so if some rogue agent decides to change my production database schema,
you need to know why it decided to do that. Not just that it did it, it's about auditing the machine's thought process.
I see. And then you have infrastructure players like Docker jumping in. They join the AAIF as a gold member, which tells me they're trying to standardize the plumbing underneath all this.
Right, and standardization means adoption, which immediately puts security right at the front of the line. If these agents are autonomous, you absolutely have to sandbox them.
Which is where some of these platform updates get really interesting. Let's talk about the Lima project. That v2.0.0 release from November 6 was a pretty big step.
It was huge, because it tied expanded AI workload support directly to a security model. Lima brought in GPU acceleration for Linux VMs on macOS.
Using the Crunkit VM driver?
Exactly. And the takeaway there is that it enables secure execution inside a VM sandbox. You can't let the agent just run wild with access to your host file system.
And Docker's doing something similar, right? They're rolling out experimental sandboxes.
Container-based ones, for now. They isolate the agent's workflow, but they still mirror your local workspace, so it's still useful for developers. They're supporting Claude Code, Gemini CLI.
But the plan is to move to micro VMs.
And that detail is so telling. Standard containers give you process isolation, which is good, but micro VMs give you hard kernel-level isolation. That tells you the industry views these agents as a fundamentally higher risk than a normal app.
It makes sense. And beyond just safety, it's getting easier for developers to even get started. For Windows users, the Docker Model Runner now supports VLLM.
That's a high-throughput inference engine.
Right, and you can run it directly on Docker Desktop with WSL2 and an NVIDIA GPU. Suddenly, powerful local AI development is something you can actually do without a massive cloud bill.
And that's scaling up, too. Look at the Replit and Google Cloud partnership. They're pushing this idea of vibe coding with Gemini and Imagen models straight to the enterprise. This isn't just for hobbyists anymore.
Okay, so we have the tools, we've got the standards forming, we have sandboxes for these autonomous agents, but none of it matters if the foundation it's all built on is crumbling.
Yeah.
You can't ignore the day two operational reality.
Absolutely. Day two is where it all gets real. You're past the fun setup part, and now you're just wrestling with complexity and troubleshooting. Most places have basic monitoring. but very few have achieved that deep causal observability.
The ability to know the root why behind a failure.
Not just that a CPU metric spiked, and the business pressure is just relentless. We saw data showing over 70% of organizations need to cut deployment times in half compared to just 3 years ago.
Wow, by half. That's what's driving this huge push for automation and AI ops.
And you can see AWS responding directly to that. I mean, the AWS Lambda Managed Instances feature is a perfect example.
Oh, that is so cool. You get the serverless simplicity of Lambda, but it's running on a dedicated EC2 instance under the hood.
So you get access to specialized hardware, better pricing models. It's a huge win for migrating older, thread-safe workloads without a total rewrite.
And for anything real-time, especially with AI, latency is everything. The Amazon API Gateway Response streaming feature is a direct attack on that. It cuts down the time to first byte.
TTFB. It's such a critical metric for interactive apps. If you're building a chatbot, that first response has to feel instant. This helps with that, whether you're using Lambda or just an HTTP proxy.
Speaking of performance, global resilience needs global connectivity. We saw AWS launch FastNet, that new transatlantic cable.
320 terabits per second, that's a lot of capacity. It's about building resilience for this massive spike in demand we're seeing from cloud and AI workloads.
And with more complexity comes the need for better diagnostics. CloudWatch is adding some much-needed features.
Like deletion protection for log groups. It sounds small, but if you're in a regulated industry, accidentally deleting your audit logs is a nightmare scenario.
Yeah, that's a career-limiting move.
It is. But the real game changer is the AI integration. CloudWatch incident reports can now walk you through a chat-based 5 whys analysis.
That is invaluable. Instead of a stressed-out engineer digging through logs at 3 a.m., an AI can start that causal analysis process, asking, why did that happen? It gets you to the root cause so much faster.
And on the dev side, we're seeing tools mature to the point where they're actually reducing complexity again. The DAPRA project just graduated from the CNCF.
DAPR is so smart. It's an intelligent sidecar that handles all the messy parts of microservices messaging, state, observability, even AI integrations. It lets developers just write business logic again.
It's a great abstraction layer. And for Kubernetes users, the Istio ambient mode with Calico integration is another big step towards simplification.
Sidecarless service mesh. That's a huge deal operationally. You get the security benefits like MTLS and traffic control without the memory overhead and complexity of injecting a sidecar into every single pod.
It's all about reducing that operational friction without sacrificing security.
Okay, so we have brilliant autonomous agents. We have resilient observable infrastructure. But this is where we have to hit the pause button and talk about reality. Because the best tech in the world still gets beaten by security debt and, well, human error.
And we have two massive glaring wake-up calls to talk about. Let's start with the Postman Workspace leak.
Unbelievable. A year-long investigation found over 30,000 public Postman workspaces were leaking sensitive data.
And we're not talking about test data. We're talking hard-coded API keys, production tokens, credentials, the kind of stuff that lets an attacker into your cloud account to spend your money.
30,000. It's not a breach. It's an epidemic of apathy. The weak link wasn't some complex exploit. It was someone clicking Make Public on a workspace with production keys in it.
It's a fundamental failure of hygiene caused by bad defaults in a collaboration tool.
And then you have the other end of the spectrum, the critical, scary vulnerability. React 2 shell.
The big one, CVE 2025-55182. This is a 10.0 on the CVSS scale, maximum severity. It affects React Server Components and Next.js.
When I see a 10.0, everything else just stops. This allows unauthenticated remote code execution. Reports say it has a 100% success rate against default configs.
So the very building blocks of the modern web are vulnerable. It's a huge blow to confidence.
And these failures happen even at the best companies. The Cloudflare outage on December 5th is a fascinating example.
It was only 25 minutes, but the cause? A configuration change was made to disable a test file for their way.
A totally benign change.
Supposedly. But it exposed a latent, undetected bug deep in their proxy's rules module, and that cascaded into HTTP 500 errors that took out about 28% of their traffic.
So a change meant to improve something pulls a thread that unravels the whole system. That's the definition of complexity risk.
It really is.
But on the other hand, you have amazing examples of process hygiene. GitLab deploys to their main site up to 12 times a day.
Using their own platform, which is amazing, and they do it with zero downtime because of that hygiene canary deployments, progressive rollouts, backward compatible migrations. It's the gold standard.
But pipelines can still be broken by the dumbest things. The example of the .NET 10 project failing in an Azure pipeline was just perfect.
Because the directory.packages.props file was capitalized wrong.
Exactly. A single capital letter. It worked on Windows and Mac OS because they don't care about case sensitivity, but the build was on Ubuntu, which is strictly case sensitive. Boom. Broken build.
It's the kind of thing that makes you want to tear your hair out.
It is, but it's such a good reminder. Let's talk about the people in this process. Estimates. Developers hate them.
Universally. And they're essential for the business to plan anything, but they're disliked because they are, by definition, uncertain, and they get treated like rigid, unbreakable commitments.
The problem isn't the estimate. It's the failure of leadership to manage expectations around that estimate.
100%. And that leads right to the other human factor. On-call rotations.
Right. Being on-call can absolutely accelerate your career. You learn the system so deeply, you build stress tolerance.
But the downside is huge. It carries serious health and lifestyle risks if it's not managed well. The consensus is that it's only worthwhile if leadership actively works to control the negative impacts, like sleep deprivation. Otherwise, it's just destructive.
And with AI now spitting out code faster than we can read it, our job as human reviewers has to change.
It has to. We can't check syntax anymore. We have to look at the bigger picture. Is this reversible? Is the scope right? Is the abstraction coherent? Those are the conceptual things AI still struggles with.
You know, this whole conversation has really brought us full circle. We started at the height of innovation autonomous agents, global safety protocols.
And we ended up back at the harsh reality of 10.0 vulnerabilities, process friction, and simple typos. The entire future of this field hinges on managing those two extremes. The push for intelligent automation versus the need for absolute fundamental stability.
It's the trade-off everyone is trying to solve. And it makes me think, we saw that Cloudflare's bug was exposed by a change intended to improve something. So with these highly autonomous AI agents, how do we make sure the very tools we design for safety, the sandboxes, the protocols, don't become the complex mechanism that creates the next maximum severity bug? This new world demands more than just better code. It demands a level of clarity and strength in our safety protocols that I'm not sure we've achieved yet.
It's definitely something to keep in mind as you plan your next deployment.
Thanks for joining us today. Until next time, keep building securely.
Spoken Tech for your ears.